Welcome back to Applied Mathematics. In this video, we're going to be solving polynomial equations. We've already seen the fundamental tool of solving polynomial equations. That is the zero product rule. If I have an equation like x squared plus 3x minus 10 equals 0, we can factor the equation. I need two numbers that multiply together to give me negative 10 and add together to give me positive 3. In this case, those numbers are positive 5 and negative 2. We can use those numbers to factor the equation. I did it in one step here, but if you wanted to write it out in a couple of steps, there's nothing wrong with that. Then we use the zero product rule to split this up into two linear equations, x plus 5 equals 0 or x minus 2 equals 0. If x plus 5 is equal to 0, x is equal to negative 5. And if x minus 2 is equal to 0, that means that x is equal to positive 2. When it comes to applications of polynomial equations, very often there is a useful and a less useful solution. We don't have an application in mind here. We don't have any information about what we have. We just have some numbers. So I don't know if one of these is more useful or less useful than the other. I have to report all of my solutions. One of the things that can cause a lot of students confusion when it comes to working with polynomial equations is making sure that we have 0 for the zero product rule. X squared minus 16 equals 4x plus 5. The left-hand side of this equation, x squared minus 16, can be factored. It factors to x plus 4 times x minus 4 as the difference of two perfect squares. But because the right-hand side of the equation is not 0, factoring is not helpful. Instead, the first thing we have to do is rearrange the equation. Right? Subtract 4x from both sides of the equation, subtract 5. Negative 16 minus 5 is negative 21. And on the right-hand side, 4x minus 4x is 0, 5 minus 5 is 0. So we have 0 on the right-hand side of the equation. Now, it's in a form that we can factor. I need two numbers that multiply to negative 21 and add to negative 4. In this case, it looks like negative 7 and positive 3 are going to fit the bill. Then we can use the zero product rule. And we can solve and we get these two possible solutions, x equals 7, x equals negative 3. Right? This process absolutely works. It doesn't always work because, as we've seen in our discussion of polynomials, not every polynomial can be factored. The nice thing about this process is that it will ensure that we get exact solutions, and in mathematics, exact solutions are nice. But in the real world, in everyday life, that's not always the case. And so, the next thing I want to do is look at an equation that is not so nice. How about 4.9x squared plus 12x minus 170 equals 0. This is a kind of equation that is very common in the study of kinematics, in the study of motion. I think I went through an example in an earlier video using this equation, right? Distance is initial velocity times time plus 1/2 times acceleration times time squared. In this case, I'm using x instead of t as my time variable. That's okay. That just makes it look more like algebra. But using metric units, these kinds of numbers are fairly common and also make things very challenging because I don't want any part of trying to factor when I have a decimal number involved. So I'm looking for another tool. There are a couple of other places that you can go. If you happen to have a calculator like a TI-36X Pro, the next place I'm going to go is the calculator itself. You might notice above the cosine button on this calculator, it says PolySolve. And if I go to PolySolve, it gives me this menu. The first option there says ax squared plus bx plus c equals 0. And if we play a matching game, you should notice that the equation that I have here is this equation. A is 4.9. B is 12. And C is negative 170. So if I choose PolySolver, hit enter here, it will ask me the value of A. I'll plug in 4.9. It will ask me the value of B. I'll put in 12. It will ask me the value of C. I'll put in negative 170. It will now ask me if I want it to solve. I will hit enter to tell it, yes, I do want it to solve. And it will give me a solution. It gives me that x1 equals 4.7915, etc. I have two significant figures in all of my entries, so I'll round that to two significant figures and call it 4.8. I also have this up and down arrow over here, and if I hit down, it will give me the second solution. x2 equals negative 7.2. I have the ability to now do further calculations by continuing to work with this. And if I scroll back up, I can put new numbers in and I can solve the whole thing all over again. So my calculator has a polynomial solver built in that can solve this equation for me without me having to worry about doing anything. If you have this calculator, that's fantastic news, right? Your calculator can do the work for you. You just have to recognize that you have a quadratic equation, you have a polynomial equation, you've gotten the right side equal to 0, and you can play your matching game. But what if you don't have this calculator? I guess is the next question. Let me do my best to copy this equation without any of my notes. Although honestly, my notes are probably still going to be helpful. Because that same process that the calculator uses is something that we can know. The formula looks incredibly ugly. But if we have an equation in the form ax squared plus bx plus c equals 0, we can use the quadratic formula. And the quadratic formula tells us that the solution is going to be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. We just have to figure out what a, b, and c are, plug them in here, and go from there. One of the things that I want to point out about this formula before we dive into it is that square roots can be a little bit problematic. We're going to be studying a little bit later on how to deal with things involving square roots and negative numbers and bad things that can happen there. So to make sure that everything is going to work, I generally recommend just looking at the stuff under the square root first. That will also let us deal with the plus or minus a little bit more effectively. So we'll plug everything into our calculator in a couple of steps here. This stuff under the square root is called the discriminant. That's a long name for it. I don't care if you know the name or not, but it will be very helpful to understand why I call it D. All right, but we need B. B is still 12. We need A, which is 4.9, and we need C, which is negative 170. We then need a calculator. Without a polynomial solver, we just need 12 squared minus 4 times 4.9 times negative 170. And my calculator tells me that that is 3,476. Right. I'm not going to worry all that much about significant figures here. I'm just going to kind of assume that things are going to work out in the end because this calculation is kind of on a hair trigger, and so rounding too much too early can cause bad things to happen. Right. But I did notice that all of my entries had two significant figures, so rounding my result to have two significant figures as well is probably the right thing to do. Right. But now that I know this discriminant, I can plug in everything. X equals the opposite of B. B is 12, so we have negative 12 here, plus the square root of my discriminant, 3,476, all over 2 times A, which is 4.9. Right, so that's the next thing I want to punch into my calculator. I'm going to hit negative 12 plus the square root of 3476 all over 2 times 4.9. And my calculator will tell me that this comes out as 4.791, etc. I'll round that to two significant figures and call it 4.8. The other solution is the same thing, except instead of having a plus sign here, it has a minus sign. I don't want to have to type the whole thing, so if I hit the up key a couple of times on my calculator, and then I hit enter, I can select that expression that I just punched in, and I can navigate through the expression until I get to that plus sign, turn it into a, hit the right key, turn it into a minus sign, hit enter again, and I get that x2 is negative 7.2. Right? This formula is exactly what the calculator does when you hit the polysolve button on it. So if your calculator does not have that feature, you can memorize the quadratic formula and you can get the same answer in not that much more time. All right. Finally, it would not be right if I did not end this video by explaining to you how easy it is to memorize the quadratic formula, because it can be set very nicely to song. I've had debates with a couple of people over which song it is best to set it to. My preference is Row, Row, Row Your Boat. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And now you'll be humming nursery rhymes as you complete your exams, and that's really what I'm here for. Right, with that, I think I'll wrap up. Thanks for joining me. See you next time.